Welcome everybody. Today we're going to be talking about direct variation. So what direct variation is we have a couple lines here and a couple graphs. The properties of those graphs is that the graph of a direct variation equation is a line through the origin. So our line goes through the origin. The slope of the graph of y equals ax is a. So a is our slope, just like it would be in y equals mx plus b. And our constant variation is m, or our slope. So our line goes through the origin, 0, 0. Here, if we graph these, we know that we don't have a y-intercept, so we know that this is direct variation. If we have direct variation, we know that it goes through 0. So then we can just use our m to figure out our graph. Our m here is 2/3. So we're going to have a rise of 2, a run of 3. So we're going to go up 2 over 1, 2, 3. The opposite of that is down 2 over 1, 2, 3. So our line is going to go through our origin, and we have a line of direct variation. Our second problem, we need to get y by itself, so we need to divide by 12. So we get y equals negative 24x divided by 12, which is negative 2x. We don't have a y-intercept, so we know that this is direct variation. It's going to go through the origin. So we're going to have a point at 0, 0. Now our slope is m equals negative 2. We don't have a rise over run yet, so we need to put a 1 underneath it. So our rise then is going to be negative, so down 2 and over 1, down 2 over 1, down 2 over 1. The opposite is up 2 to the left 1, up 2 to the left 1. So that is our line for the second problem. Here we have to tell whether the equation represents direct variation or not. If so, identify the constant of variation. Now if you remember, the constant of variation, that's our slope. So we need to figure out if these have direct variation. So that means that we're not going to have a y-intercept. So we need to get y by itself. We're going to add x to move it to the other side. So we get y equals x plus 1. Now this one has a y-intercept. That's plus 1, so we know that this one is not direct variation. Here we're going to move our 2x over by subtracting because it's positive. We get y equals negative 2x plus 0. Now this one, it looks like we have a y-intercept, but because this is 0, that means there's nothing there. It's going to go through 0, so yes, this is direct variation. And our constant of variation, so our C, we'll say CV, equals negative 2. Our constant of variation is negative 2. That comes from right here, our slope. This last problem, we're going to subtract 4x. So we get negative 5y equals negative 4x. Now, plus 0, but we don't need to write that. So we can divide by negative 5. So 2 negatives is going to make a positive, 4/5 x. So this does not have a y-intercept. So yes, this is direct variation. Our constant of variation, or CV, is 4/5. So this one says the graph of direct variation equation is shown. Write the direct variation equation, then find the value of y when x equals 8. So we know that we're not going to have a y-intercept. Our y-intercept is 0. So we know all we're going to have is y equals something x. So this line is going down, so we know it's going to be a negative something. We're going down 1, 2, and over 1, 2. So our rise over the run is negative 2 over 2, but we can simplify that to negative 1x. Now if we're going to find the value when x equals 8, we go y equals negative 1. Now instead of our x, it's going to be 8. So negative 1 times 8 is negative 8. Y equals negative 8. Same thing for this problem. We know we have a y-intercept of 0, so we don't have anything there. We have y equals something x. This one is going positive, so we can count up from here to the next point that we have. So we're going up 1, 2, 3, 4, 5. And we're going over 1, 2, 3, 4. So our run is 4. So y equals 5/4 x. Now if we do this, when x equals 8, we'll have y equals 5/4 times 8. So if I do this problem, then we have 5/4 times 8, and then we can make that into a fraction by 8 over 1. 5 times 8 is 40. 4 times 1 is 1, or 4. Now we have 40 divided by 4, which is going to give us 10. So y equals 10. Tell whether the equation represents direct variation. If so, write the direct variation equation. So here's our direct variation equation, y equals mx. So what we got to figure out is if at 0 on our x, it's also going to be 0 on our y. So this looks like it's going down by 5s. So minus 5, minus 5. If I go from 5 minus 5, my y is going to be 0. So this does have direct variation because it's 0 at both the x and the y. Now our equation, y equals, the m is our pattern, or whatever it's going down by. So this looks like it's going, if I count up, it's going up by 5. This is a positive variation, so we'll have 5x. Now our pattern was going down by 5. That's because we were looking for when it was 0. But when we're looking to see what our equation is, we look to see which direction it's going. Here, well, we need to figure out where y is when x is 0. So x is 0 is going to be somewhere in here, right between these two. Now, it looks like this is going up by 2's. So if I put a 2 in between here, 3 is 4, 1 is 2, so that means 2 has to be 3. So it's going down by 1's. So 1 is 2, that means 0 has to be 1. This does not have direct variation because this should be 0, 0. So no direct variation. So it says, given that y varies directly with x, use the specified values to write a direct variation equation that relates x to y. So what we're given here is x equals -6 and y equals 15. If we use this equation, y equals mx, we already know two of those values. We know that y equals 15 and x equals -6. So all we need to find then is what m is. So if we were going to do this problem here, we got to get m by itself because that's what we're looking for. So m and x are touching, so I'm going to divide by x to get x to the other side. So our new equation then is m equals y over x. So then if we have y over x, what we need to do then is make this into our equation. So we have m equals, our y is 15, our x is -6. So now we can just simplify this by dividing by 3. And we get 15 divided by 3, which is 5, and -6 divided by 3, which is -2. So this is our m. If we're going to write an equation that looks like y equals mx, we would write y equals 5 over -2x. If we go over here, again we know our x and we know our y. So what we're going to have then is 1 over 1/4. So our m equals 1 over 1/4. Now we can't have a fraction on the bottom here, so I'm going to turn this into a decimal. 1/4 as a decimal is 0.25. If I divide this, I'm going to figure out how many 0.25s go into 1. So that's basically figuring out how many quarters go into $1. And we know that how many quarters go into $1, and that's 4. So our m equals 4, which means our equation is going to equal y equals 4x. Alright, last problem. We're talking about downloading files here. It says the table shows the amount of time t in seconds it takes to download a file of size s in kilobytes. Explain why s varies directly with t. Well, we said that s is the size and t is the time, so we know that as the size gets bigger, the t is also going to get bigger, because as a size goes up, it's going to take longer. So s and t vary directly because our slope is the same. As the size goes up, the t also goes up. So if we look down at our table here, it looks like as our size is going up, our time is going up. Our size is going up, our time is going up. So the second part says write a direct variation equation that relates s and t. So what we're going to do is we're going to take our equation y equals mx, and just like we did last slide, we're going to divide by x, because what we're looking for is our slope. Our slope is y over x. In this case, our slope is s over t, or sorry, t over s. So here, if we're looking for our slope, it would be 15. Hold on one second, I might have gotten this wrong. Sorry, this is flipped around. It should be s over t. So s over t, we're going to have 420 divided by 15. Let me take my calculator out and see what 420 divided by 15 is. $420 divided by 15 gives us 28. Then we could do 840 divided by 30. That's also going to give us 28. And then 1,260 divided by 45 equals 28. So we just said that the slope is the same. That shows that our m equals 28. If we write an equation like this, our m is going to equal 28, so we could say y equals 28x, or in this case, s equals 28t. So this says, how long will it take you to download a 800 kilobyte file? Round your answer to the nearest second. So this is 800 kilobytes, so that's the size, not the time. So I'm going to put 800 in the size spot and have 28 for our t spot, for 28 next to our t. So we're just going to solve this, divide by 28. So we get t equals 800 divided by 28, which gives us 28.57. But it says round your answer to the nearest second. So t is actually going to equal 29 seconds. So it takes 29 seconds to download an 800 kilobyte file.